Welcome to this comprehensive guide on the search command, which forms the foundation of Splunk Processing Language or SPL. The search command is your gateway to unlocking the power of Splunk data analysis. In this series, we'll master three essential components: wildcards for flexible pattern matching, Boolean operators for logical combinations, and field filtering for precise data extraction. These skills will transform you from a beginner into a confident SPL user, capable of finding exactly what you need in your data. The search command is the cornerstone of every SPL query. Think of it as your data retrieval engine that filters and extracts events from your index data. Every time you want to find specific information in Splunk, you're essentially using the search command to sift through millions of events and return only those that match your criteria. For example, when you write search index equals web status equals 404, you're telling Splunk to find all events in the web index where the status field contains the value 404. This simple yet powerful command is the starting point for all data exploration in Splunk. Understanding search syntax is crucial for effective SPL usage. There are two ways to use the search command. First is implicit search, where you simply write your search terms without explicitly mentioning the search keyword. For instance, index equals web error automatically assumes you want to search for these criteria. Second is explicit search, where you explicitly start your query with the search command, like search index equals web error. Both approaches yield identical results, but the implicit method is more commonly used due to its brevity. Splunk intelligently recognizes your intent and applies the search function automatically. Wildcards are powerful tools that allow flexible pattern matching in your searches. The asterisk wildcard matches 0 or more characters, making it perfect for broad searches. When you search for error asterisk, you'll find events containing error, errors, error message, and any other text starting with error. Similarly, asterisk failed asterisk will match any event containing the word failed anywhere in the text. The question mark wildcard is more precise, matching exactly one character. For example, user question mark will match user 1, user A, but not user 12. Use file question mark.log to find files like file1.log or file.log, but not file12.log. Boolean operators enable you to create complex search logic by combining multiple conditions. The AND operator requires both conditions to be true. When you search for error and status equals 500, only events containing both error and a status field of 500 will be returned. The OR operator is more inclusive, returning events where either condition is true. Searching for error or warning will find events containing either error or warning or both. The NOT operator excludes matching events from your results. Using not user equals admin will return all events except those where the user field equals admin. These operators can be combined to create sophisticated search queries. Field filtering allows you to search within specific data fields for more targeted results. Equality filtering uses the equals sign to match exact field values. For example, status equals 404 finds events where the status field is exactly 404, while user equals admin locates events where the user field contains admin. Comparison operators work with numeric fields to create range-based searches. Use bytes greater than 1000 to find events with byte counts exceeding 1000, response underscore time less than or equal to 5 for fast responses, and status not equal to 200 to exclude successful HTTP requests. These filtering techniques help you pinpoint exactly the data you need. Let's examine real-world applications of search commands. To find failed login attempts, combine multiple fields. Index equals security event type equals login and action equals failure. This query searches the security index for login events that resulted in failure. For error analysis with wildcards, use source type equals access underscore asterisk in parentheses error or fail asterisk parentheses not user equals system. This complex query searches access logs for error or failure patterns while excluding system user events. Notice how parentheses group the or condition, ensuring proper logical evaluation. These examples demonstrate how search commands, wildcards, Boolean operators, and field filtering work together to create powerful targeted queries. Following best practices ensures efficient and accurate searches. For optimal performance, always specify your index first in the search string, as this dramatically reduces the data Splunk needs to examine. Use specific field filters rather than broad text searches to improve speed and precision. Limit your time ranges appropriately. Searching years of data when you only need recent events wastes resources. For syntax clarity, use parentheses to group complex logical conditions, ensuring your Boolean operators work as intended. Always quote field values that contain spaces, like message equals quote error occurred quote. Remember that field names are case sensitive, so user and user are different fields. These practices will make your searches faster, more accurate, and easier to maintain. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.